Ever written a function, called it, and then nothing? Or worse, undefined? You told it to do something, but it didn't tell you anything back. That's a problem. If your functions can't give you data back, your code becomes a tangled mess of side effects and global variables, or it just breaks. You can't chain operations, you can't reuse logic cleanly, and debugging becomes a nightmare. By the end of this video, you'll not only understand how to get data back from your functions, but why it's the fundamental building block for writing robust, readable, and truly powerful code. The silent treatment. Why functions go quiet. Okay, so you write a function to calculate something, say, a user's age based on their birth year. You run it, and it seems to execute, but when you try to use that age later, it's just gone. What happened? Real talk. Without a return statement, a JavaScript function implicitly returns undefined. It's like sending a letter without a return address. The post office delivers it, but you'll never get a reply. The data you created inside, it vanishes as soon as the function finishes, because it lives only within that function's local scope. The magic word, return. The solution is simple, yet incredibly powerful, the return keyword. When JavaScript hits return inside a function, it does two things. First, it immediately stops executing the rest of the function, and second, it sends whatever value comes after return back to wherever the function was called. It's like a direct line of communication. You can return any primitive data type, numbers, strings, booleans, even null or undefined explicitly if that's what your logic demands. Honestly, returning null can sometimes be a bit of code smell if not handled carefully, but we'll get to that. The point is, your function now has a voice. Beyond primitives, objects, and arrays. The real power of return value shines when you start returning complex data structures like objects and arrays. Instead of just a single number, you can get back an entire user profile, a list of products, or configuration settings. This is how you build modular, reusable pieces of code that truly represent real-world data. Imagine a function that filters a list of items or transforms them. You don't want to modify the original list directly. That's generally a bad practice, leading to unexpected side effects. Instead, you return a new array or object with the desired changes. This concept of immutability is crucial for predictable code, especially in larger applications. Unpopular opinion. Functions that modify their arguments directly without returning anything are often harder to reason about. The art of the early exit. Beyond just getting a value back, return has another super useful trick. It stops the function immediately. This is fantastic for what we call guard clauses or early exits. Instead of nesting if statements deeper and deeper, you can check for invalid conditions at the top of your function and return early, often with null, undefined, or an error. We've covered the basics, but here's where return values go from useful to absolutely essential for building flexible, powerful applications. This isn't just about getting data back, it's about structuring your entire code base. This makes your code much flatter and easier to read. You handle the edge cases first, then focus on the main logic without indenting into oblivion. Honestly, this is one of those small changes that dramatically improves code clarity. I genuinely think deeply nested if statements are a readability killer, and early returns are your best defense. Building blocks, chaining functions. Here's where it gets really interesting. When a function returns a value, you can immediately use that value as the input for another function. This is called function chaining, and it's a cornerstone of functional programming and readable, expressive code. Think about how you use array methods like map, filter, and reduce. They all return new arrays, allowing you to chain them together. Quick side note, this chaining relies heavily on functions returning new data rather than modifying existing data. This concept is called immutability, and while it might seem like extra work at first, it drastically reduces bugs and makes your code easier to debug. If a function always returns a new value and never changes anything outside its scope, it's called a pure function, and those are genuinely a joy to work with. Handling errors and edge cases, return versus throw. This frustrates me because a common debate is, when should a function return a special value like null or an empty array for an error, and when should it throw an actual error? Some devs swear by returning null or undefined to indicate failure. Others hate it. Here's my take. If the failure is a valid expected outcome for your function, return a special value. If it's truly an exceptional, unexpected problem that prevents the function from completing its purpose, throw an error. For example, if a findUserById function doesn't find a user, returning null might be perfectly fine. It's an expected outcome. But if your process payment function fails because the credit card API is down, that's an exceptional situation, and you should probably throw an error. This distinction is subtle, but critical for robust applications. Wild, right? Return values for asynchronous code and closures. Return values aren't just for immediate data. In modern JavaScript, you'll frequently return promises from asynchronous functions. When you await an async function, you're essentially waiting for that promise to resolve and return its eventual value. This is how you manage complex operations like fetching data from an API, waiting for a file to load, or interacting with a database. And here's a mindbender. You can even return functions themselves. This is the basis of powerful patterns like closures and higher-order functions. A function that returns another function often creates a closure, meaning the inner function remembers variables from its outer scope, even after the outer function has finished executing. I know this part is dense. Stick with me. It's a game changer for advanced patterns. Let's recap. Functions implicitly return undefined if you don't use return. The return keyword sends data out of a function and immediately stops its execution. You can return any data type, from simple primitives to complex objects and arrays. Early returns are a powerful pattern for cleaner error handling and readability. Returning values enables function chaining and building highly modular systems. The choice between returning null and throwing an error depends on if the failure is expected or exceptional. The key takeaways: always consider what data your function needs to give back. Prioritize returning new data, immutability, over modifying existing data. Use early returns to improve code readability and handle edge cases gracefully. Embrace function chaining for more expressive and concise code. Master return values, and you'll write more robust, testable, and maintainable applications. If this helped you finally click with how return values work and why they're so important, consider supporting the channel. Every bit helps us create more videos like this, keeping them free for everyone. Drop a comment with your thoughts on when you prefer to return null versus throwing an error.